Right, hello, welcome to the AP Stat videos. This is video 1, chapter 1, lesson 1. Here we go, just as a quick brief overview of how these notes work. Chapter 1 has a 1.0, none of the other ones have a 0.0. They all start at 0.1. But you see at the top, this says book notes. Book notes are supposed to be filled in by you. I might reference the book notes in the lesson, but for the most part, I will just be going over what's called the class examples, as we'll see in just a second. You are supposed to fill these out from the book itself. This filled in copy is online, so you can go copy this if you want. The book is going to have more detailed information than just definitions like what this is here. So please go and make sure you read the book. There's tips and tricks and all of this stuff. Here's a nice little graphic for you to make sense of stuff. Now this is 1.1. Again, everything starts with book notes. So here's the book notes. Mostly just definitions before we get to class examples. So most of the videos are going to be class examples, me going through these. It's basically, let's explain what these things are and put them into practice in some actual examples. Again, I might reference the book notes, go back and forth a little bit depending on what explanations are needed. But for the most part, it's just going to be going through these class examples. Let's just start. Chapter 1, lesson 1. It says Spotify tracks data about listeners. The frequency table summarizes the distribution of ages for a sample of 100 Beatles listeners. So there you have the table right here. That shows you the information. And A asks you to identify the individuals in a set. Remember, individuals do not have to be people. They can be things. It's just what is the data? What is the question about? In this case, we're looking at very specifically the 100 Spotify users who listen to the Beatles. All right, we're only looking at the Spotify users who listen to the Beatles, very specifically the 100 in this data set. All right, then it says make a frequency bar graph of the data and then describe what you see. So let's go ahead and make ourselves a bar graph. In order to do that, we need a y-axis and we need an x-axis. Leave yourself some room. Now, frequency bar chart. Frequency basically just means number, how many in each one. A relative frequency is percentage. So you'd have to convert all of these into a percentage. Nice thing is for this one, it's out of 100, so that kind of is the percentage, anything divided by 100, but that's okay. So my biggest number is 33, which means I have to get up to at least that. So I'm going to start at 0 down here, and I'm just going to go up by 5s. You can make this however you want. So there's 5, 10, 15, 20, 25, 30, and I got to get up to 35 to get that 33. There's my y-axis. Let's label that. This is number of listeners. My x-axis is going to be my age categories. So we'll put age down there. This is 17. I'm going to put 17 minus for 17 and under. And then we have 18 to 24. We have 25 to 34. We have 35 to 44. Let's extend this out a little bit. And we have 45 to 54. Oh, let's put that a little bit there. 45 to 54. And then 55 plus. Apparently I needed a lot more room than I thought I did. All right. And then you're just going to go through here, bar charts. How many were 17 and under? That was only 5. So make sure we go up to 5, put it over. There it is. 18 to 24, there was 25 of them. So go up to 25. Trying to make sure that my widths here are equal. Right, I don't want one to be bigger or smaller width-wise than another. That might skew the data, or at least portray how it looks a little bit different. 25 to 34 is 33. So we going up to 33. And then 35 to 44 is 16. So go up to 16. 45 to 54 is 10. So go up to 10. And then 55 plus is 11. So there's our bar chart. Bar graph, bar chart, bar graph, whatever. Notice that I have gaps in here. Hopefully these gaps are all the same. Maybe I didn't do a very good job because I was freehanding this. Hopefully your art is better than mine. As you can see, the level of my artistic ability, not very high. So I just hold you to my level. Hopefully you can be this good. Or better, because this is terrible. All right, let's just describe what we see. So we'll just take a look at that for a second. Think about what you see, what's going on. Okay, I'm going to list a few things here. Are these the only things going on? No, probably not. There's probably more things, but, just to call some things out. So everything you do, every time you talk about things, we all need context. So we're going to start with context. So of the sample of 100 Spotify listeners. So there's my context. Let's be a little more specific. Beatle listeners, right? We Spotify, let's shorten this. Users, sorry. This is why we use pencil. Users who listen to the Beatles. Let's be super specific about our context. Who Beatles, who listen to the Beatles. There we go. Sorry, English is not great. I math better than I English, so it's all good. Okay, and just call out the most basics of things. What's my biggest group? The 25 to 34 group. So of the sample of 100 Spotify listeners, the most frequent ages I ran into my little thing there. The most frequent ages are 25 to 34. Okay. While the least frequent were 17 and under. All right, just call out the most basics of things. If you wanted to describe some kind of trend, which we'll see kind of later on, there is some sort of trend going on here. As we move more in the year, we'll learn more things that we could talk about, but that's fine. We can also just take this deeper if we wanted to. Why does the graph look like this? First off, who are the Beatles? If you don't know who the Beatles are, they were a band. Back in the day, they were the most popular band of their day for quite a long time. The Beatles, if you haven't listened to some Beatles, you should definitely go listen to some Beatles. That is awesome music there. But it's interesting that the biggest group is actually the 25 to 34-year-old group. And not like the older group, because the Beatles were popular when these people were young, right? And music was blowing up, potentially even these people. So why is it that this group is the highest and the group that we thought would be the highest actually isn't? And I think if you think about it for a second, you could probably come up with some ideas. I think the biggest idea is who, in general, regardless of the Beatles, is on Spotify. And I think the answer is not really these people, especially not these people, right? Technology is weird to them. It's foreign to them. They just struggle a lot. My parents are here, and it's a very interesting thing, right? So it's not that surprising in that instant, in this sense, because these people probably aren't on Spotify a lot, right? Whereas these people are on Spotify a lot, right? So then why does it make sense that here, so there's the biggest, I think, again, that age group is probably one of the bigger age groups on Spotify. And also, who are those people? These people are the children of these people who, although they are not on Spotify, they grew up listening to the Beatles. So when these people were growing up, what did they listen to? These people's music, which is the Beatles. And whether you like it or not, you have some affinity for the music your parents listened to. And so, yes, it is not surprising that a lot of 25 to 34-year-olds will listen to the Beatles because that's what they grew up listening to. All right, so you can always dive deeper into the stats. It's one thing to get the stats, another thing of what do the stats tell you, and why are the stats that way? Is there a reason why we see, even though if we just took the whole population and said how many people who listen to the Beatles, these groups should definitely be the highest, for sure, right? But they're not on Spotify, right? So there are reasons why the data is the way it is, and that definitely helps explain how things are going, right? So the frequency bar graph, pretty basic, 1.1. We're starting off easy. Things you should hopefully already know. Okay. All right, so it's question number 2. It says, is Steph Curry the greatest of all time? In the 17-18 regular season, basketball player Stephen Curry averaged 6.1 assists per game and 1.66 steals per game. Explain what was wrong with the following graph and how to make it better. What is wrong with this graph? I'll give you a minute or two. You can pause the video, figure out what's wrong with it. And I think the obvious answer is, this fits, right? That's about 6.1-ish, right? And then this is about 1.6. So that fits, right? Everything is all good. The answer is no, and I alluded to it up above. And this is a nice infographic. It looks cool. We got basketballs instead of bars. Like, it's great. It's cool, except these widths are different. And what happens is you want your data. When you represent your data, you do not want people to misinterpret that data. So you got to think to yourself, what are people going to see? Are people going to see the heights of these basketballs, or are they going to see how big the basketballs are, and in a sense, like the volume of the basketballs? And that's the case here. The volume of assists are way bigger than the volume of the steals, which is fine because this is bigger, but it's unproportionally so, right? Volume or area, I guess I've been saying volume. It probably should be area. Volume is 3 dimensions. But not only is this taller this way, which it should be, but it's also wider this way. So the area is just a lot bigger proportionally to steals than the actual number assists to steal ratio, right? So that's the problem with this, is that people's eyes are going to latch onto the area and not necessarily the graph itself. So this, while again accurate here, is going to misrepresent, and people are like, wow, he has so many more steals, assists than steals. And while he does have more, it's not, as significant as this portrays it to be. So I know I just said a lot without writing a lot, but here it goes. Although the heights of the basketballs, I'll shorten that to b-balls, is correct, or are correct, let's be grammatically correct. Our eyes respond to area. Let's see here. That's right. Curry averaged about 3 to 4 times more assists than steals. But this graph. That's right. But the areas are about 10 times bigger. If you do the math, it's close enough. All right, so that's what's wrong with it. It also says, how would you make it better? Represent each with equal length bar or equal width bars. Right? You want to highlight the thing that you're trying to show. In this case, how many assists versus steals. And so everything else should be the same except for that one bit that shows the difference between assists and steals. Okay? So there you go. Make sure that your data graphical representation, right? There's more than one that we could use. There's pie charts, there's bar charts, there's mosaic plots, there's all these other cool things. We'll get into the quantitative in 1.2. Oh, I didn't even mention the title of 1.1. We're on categorical data, but that's okay. I'm sure you can read and figure that out. Yeah, just make sure that your representation shows a good, accurate representation and does not lead the viewer to misinterpret things based on how you've represented. Okay? Moving on to the next page, page 7 here, iPhone or Android. It says the Pew Research Center asked a random sample of 2,024 adult cell phone owners from the United States which type of cell phone they own, iPhone, Android, or other, including non-smartphones. Here are the results. So this is called a two-way table, hopefully read about in the book. So we have the individual cell, right? We have the row total there, right? We have the column total there, and we have the table total down there. Okay. First off, let's just acknowledge all along, just straight out of the fact that the Android users are the far superior users. They're smarter users. The Android phone is the better phone. Nobody likes iPhones. I'm just kidding. I'm having fun. Android is definitely better though, so deal with it. Way to be a sheep and get an Apple phone like everybody else. You're just a sheep. You're a follower. Don't be a follower. Don't be a sheep. Get an Android phone. Okay. A says, what proportion of the adult cell phone users have an iPhone? So what proportion of adult cell phone users have an iPhone? Well, here we're looking at iPhone, and it says adult cell phone users. So this is everybody, right? Adult cell phone, this is the whole thing. So it's here. So iPhone use all of these people are iPhone users. So we got iPhone users over everybody. So this should be 467 over 2024. Okay, that's the proportion. That comes to a decimal of 0.231. I trust you can type that in on a calculator, right? I'm taking all iPhone users and I am putting them over everybody in the survey. Okay, so this was a row total over a column total. B says, find the distribution of ages of adult cell phone users using relative frequency. So relative frequency, what is a relative frequency? So it says of ages for adults. So I just need to take this of ages. So of ages, here are my ages, relative frequencies. So now I'm going to take this over this. I'm going to take this over this, and I'm going to take this over this, right? So for 18 to 34-year-olds, I'm going to take the total of the 18 to 34-year-olds, it's a 517, over the table total, right? So the proportion, that's a 0.255. The proportion of 18 to 34-year-olds in this study for adult cell phone users was 0.255. The 35 to 54 was 637 over 2024, which is 0.315. And the 55 plus category was 870 over 2024, which is, I don't know, I scribbled out. Apparently I did something wrong in my notes and I didn't fix it beforehand. This is what happens when you're an expert planner. Just kidding. 870 divided by 2024 is 0.4298. So we're going to go 0.430. Pull out your trusty little calculator to do that. So when you're doing relative frequencies, make sure you just look for the keywords and make sure you're going the right direction. Of ages. So of ages for cell phone owners. That means I'm doing that out of the total. Okay. So just make sure wording choice matters. Now it says what percent of cell phone owners who are 55 or older and own a cell phone. Now I'm being very specific. They are 55 and older and they have an iPhone. That is very specifically 127 of these people. But these people, who are these people? Where am I putting that 127 over? Is it all 55 plus and I'm putting over 870? Is it all iPhone users and I'm putting over 467? Or is it everybody and I'm putting over 2024? And this says adult cell phone owners. So that means it's over 2024. It's over everybody. And that means 0.063. Now it does say what percent. So that is 6.3% of these cell phone owners are 55 and older and have an iPhone. Okay. So there you go. And then here, D, it says what proportion of iPhone owners were 55 or older? So now I want 55 or older. So I'm going again. It's kind of like this first one here. Instead of going over on the iPhones, now I'm going over on 55 or older. So how many were 55 or older? Well, that was 870. Oh, I read that wrong. I apologize. Scratch that. It says what proportion of iPhone owners? Okay, so this is where we get into the weeds a little bit. Of iPhone owners. So now I'm strictly looking at iPhone owners. I'm only looking at that. I'm screwing the rest of the table. Of iPhone owners, we're 55 and older. So it's still 127. We were still looking at the right number. Oh, no, we were looking at 870. Okay, sorry. Look, this is lesson 1. I'm still a little rusty. Got to get in the swing of things. We'll be better as videos go on. Okay? So, of the iPhone users, I'm not looking at Androids or others. I'm strictly looking at iPhone users. So this becomes 127 out of the 467. Right? I'm not looking at everybody anymore. I'm just looking at iPhone users. So this is 127 over 467, and that is 0.272. Okay? Then it says, what percent of 18 to 34-year-olds owned Android phones? So this is the same idea, okay? What percent of 18 to 34-year-olds? So now I'm strictly in the 18 to 34-year-old category. I'm only looking at that category, and I want very specifically Android phones. Okay, so that is 214 over 517. That is 214 over 517. Which is 0.414, if I could write it correctly, 414, there you go. It does say what percent, so I do need to continue that into a percent, right? As a general rule, if it asks for percent, give it percent. If it asks for proportion, give it proportion. Don't give it a percent if it asks for a proportion, and don't give it a proportion if it asks for a percent. Now, if you need the proportion to give you a percent, obviously you write it down, but make sure you end with what you're supposed to be ending with. Let me make that a little cleaner for you. There you go. Okay. And then F over here says, find the distribution of cell phone types for each age group. Make a segmented bar graph to compare these distributions. I know I didn't give you a lot of space. We're going to end up drawing our graph down over here. The answer to this one is not that long, so we're going to make room, find room where you fit it. Now, It says find the distribution of cell phone type for each age group. For each age group. So I'm going to find the marginal frequencies here for each age group. So this for the 18 to 34-year-old age group. I need an iPhone, I need an Android, and I need others. So that's the way this works, right? For 18 to 34-year-olds, I'm specifically looking at the 18 to 34-year-olds. I need to look at the iPhone, I need to look at the Android, I need to look at the other. I'm going to put it over the, in this case, the column total, the 18 to 34-year-old total, right? A lot of the problems students have with this problem is figuring out, am I going this way or am I going that way? And all I'm going to say is read. Read. Find the distribution of cell phone type for age group. So for each age group, find the type of cell phone that each age group does, right? So for iPhone, that was 169 over 517, which is 0.327. Android was 214 over 517, which equals 0.414. We just found that up above. And then other was 134 over 517, which is 0.259. If I'm going too fast for you, feel free to pause the video. I'm just grabbing all this data from up here on this two-way table. Okay, so it's a nice thing about videos is you can pause and go back and whatever. All right, so now I'm on the next age group, which was 35 to 54, and Android, iPhone, Android, and other. iPhone here was 171 over 637, which was 0.268. Android was 189 over 637, which was 0.297, and then other was 277 over 637, which is, let me make these actually equal signs, 4.435. And the last one was 55 plus, iPhone, Android, other. iPhone was 127 over 870, which is 0.146. Android was 100 over 870, which is 0.115. And other was 643 over 870, which was 0.3739. Whew, okay. So there's our frequencies, okay? So as you go through all of these frequency things, what you have to decide when you read the question is, what am I looking at and what is it over, right? Am I cell over row or column total? Am I cell over table total? Am I row or column total over table total? Right? And these are the things you have to think about. But if you read the question, right, if you read A and B and C, and as we go through, it should tell you what it wants, right? So are you looking for something very specific? Or are you looking for an entire category, right? What are you looking for? So just make sure you read the question as you go. Now it says make a segmented bar chart. So let's make a segmented bar chart. Okay, a segmented bar chart here. Nice thing about a segmented bar chart is it's always as a percentage from 0 to 100. Okay, and you can kind of stack this however you want. So there's 50, 40, 30, 20, 10, 60, 70, 80, 90. Ignore the no. How do I? Sorry for that disruption. I'm recording at school and they came over the PA and I couldn't find the pause button in time. Okay, here we go. Okay, so as we do this, and when it says make segmented bar chart, my bars are going to be my three age groups, 18 to 34, the 35 to 54, and the 55 plus. Now the nice thing about these is, again, I need to represent 100% of the 18 to 34-year-olds. I need to represent 100% of the 35 to 54-year-olds. and I need to represent 100% of the 55 plus. So all my bars are up to 100%. What changes is everything else. So for my 18 to 34-year-olds, won't leave green for Android because they are, that color is green. Okay. iPhones for 18 to 34-year-olds were essentially 33%. So I need to go to 10, 20, 33%. So this was all iPhone. And then you need a key. So let's put this over here. My purple is iPhone. All right. And then my Android says this 414, so 41%. Now don't go up to 41% and do this. That's not what you do. You do 41% on top of the 33%. So this is going to be 74%, 74%. So I need to go up to 74%, which is about there. And this whole thing is Android, right? So this represents the 41.4%, right? So green is Android, right? And then the remaining should be other. So if I shade that in, and I didn't shade that in, this is other, right? So there you go. And then let's do this for all of them. iPhone for 35 to 54-year-olds was 26.8%, so 26, so it was like here. Android was 30% essentially, so 30 plus, that's 56, 57% I got to get up to. So there's that, and that means the remaining 43.5% is other. Make sure you go in the same order, right? I went iPhone, so I'm going iPhone, so I should go iPhone. Don't change the order. Don't make people think harder than they have to. Again, you want, when you display your data, it to be the easiest possible thing that people can read. All right, so 55 plus, iPhones were about 15%. Android is about 11.5, so 12% plus that 15 gets you up to about 26, 27%. So that's like here. And then you have all the old folks with those, consumer cellular phones or whatever it is, whatever that thing is. There you go. Now, I did this with color, which makes it really easy. What if you don't have color? What do you do? We'll just make things hatches, right? So maybe I hatch this way, and maybe I hatch this the other way, and I can maybe just leave this blank altogether. Or maybe I hatch this, I make X's out of this one. So they all look different. They all, if you're only using one color, they all have to look different. You can use vertical bar. Oh, gosh, I did it again. You can use vertical bars if you want. Let's take this one out. It'll be easier, right? This is cool, doing vertical bars. The only thing I wouldn't do is use horizontal bars, because then where does your horizontal bar hatch end and the other one, the next category, begin? Like let's make this easy. You can completely shade one in altogether, right? And then hatch one and leave one blank, or if you wanted to, hey, that works. I don't know, like figure it out, right? Just make sure everything has its own distinct thing. The last thing I want to talk about before we get to this last problem, even though it's not mentioned here, is it mentioned in your book notes at all as I'm flipping through mine? It is a mosaic plot. So a mosaic plot is basically a segmented bar chart, which is what this is, but it's a big box. It's one big box, the whole thing, and then while this is still segmented like this, the 18 to 34-year-olds, right, were 507. We're 25%. So they would take 25% of this, of that horizontal axis. And then 35 to 54-year-olds were 32-ish%. So they would take the next 32% of this. And so these widths, we talked about the width needing to be the same. In the mosaic plot, the widths are not the same. The widths are proportional to the category. So the nice thing about A mosaic plot is everything filled in, so there's no space. So you know which category down here is the biggest based on the width. So it gives you more information in the same amount of space. And then again, this is still, height-wise is still as it was. Okay, so that's what a mosaic plot is. Apparently it showed up on the AP exam this past year. It's basically just an extended bar chart to give an extra bit of information. That's all it is. Okay, I think you'll see one in your homework. You probably see one in the book, assuming you read the book. So make sure you do that. Okay, let's do G, and then this one is actually done. As you see, the next one is 1.2. So G says, describe what the graph in F reveals about the association between age and type of cell phone for adult cell phone users. So basically just describe what's going on, describe the trend. So it says, knowing an adult's age helps us predict what type of cell phone they have. I'm going to need more room. Leave yourself more room. Type of cell phone. Right? That's the case. And I'm going to explain this and then, again, call out one major thing. For example, the 55 plus community likely has an other phone. Right? Call out the biggest thing. 18 to 34s are relatively split. 35 to 54-year-olds are kind of split. Others still the biggest, right? But just call out some really glaring things. So, more people 55 plus have other phones. Let's be comparative. Than 18 to 34 or 35 to 54, right? Just call out the biggest thing. This graphing, this tells you something, right? Based on the age, I can predict. Does it always mean I'm going to be right? No, but if I know you're 54 or 55 plus, right? Odds are 74% of the time you got an other phone. It's a pretty safe prediction. Okay? So there you go. I was trying to keep this video under an hour. I got 37 minutes and change, so I did pretty good even with my intro. So there's 1.1. That's how these notes work. Sorry if that was kind of on the boring side in class. You're here. I'm here. We can be a little bit more dynamic with the lesson. Here it's just me and a tablet, which is not all that fun, I'll be honest. So hopefully this helps. Hopefully this helps you do your homework. If you ever miss a day, boom, all these videos are going to be here. So there it is, 1.1. Go ahead and tackle your homework, and happy mathing, people.